our team is going to discuss about Gibbs free energy and how enthalpy and entropy is being encoded in our topic. So yeah, let's get started.
Gibbs energy was developed in 1870s by Josiah Willard Gibbs. He originally termed this energy as the available energy in the system. His paper published in 1873, Graphical Methods in the Thermodynamics of Fluids, outlined how his equation to predict the behavior of systems when they are combined.
This quantity is the energy associated with a chemical reaction that can be used to do work, and is the sum of its enthalpy and the product of the temperature and the entropy of the system.
So in order to get the value of delta G, first we need to find the value of delta S, or entropy. So the equation for entropy is delta S is equal to the summation of the total number of moles times S of the product side minus the summation of the total number of moles times S of the reactants. Which is equal to so 2 moles times the value of lead oxide, which is 69.45, plus 2 moles times the value of sulfur dioxide, which is 248.5, minus the reactant side, which is 2 mole, times the value of lead sulfide, which is 91.2, plus 3 moles of oxygen, which is 205.0, so since we have mole here and mole here, you need to cancel this out, this, and also this. So 2 moles times 69.45 is equal to
138.9 joules per Kelvin.
138.9 joules per Kelvin plus 2 moles of 248.5.
497 joules per Kelvin.
Joules per Kelvin. Minus 2 moles times 91.2 is
182.4 joules per Kelvin.
Plus 3 moles times 205.0 is equal to
615 joules per Kelvin.
joules per Kelvin. So this will sum up to
635.9 joules per Kelvin.
joules per Kelvin, and this will sum up to
797.4 joules per Kelvin.
So 635.9 minus 797.4 is equal to
Negative 161.5 joules per Kelvin.
joules per Kelvin. So we have here the value for the delta S in the Gibbs formula.
So now let's find the value of delta H. Using the equation, the summation of the number of moles times H of products minus the summation of the number of moles times H of reactants. So we have here the summation of 2 moles times negative 217.86 kJ per mole plus 2 moles times negative 296.4 kJ per mole minus the summation of 2 moles times 94.3 kJ per mole times plus 3 moles times 0. So now we need to cancel the moles. So 2 times negative 217.86 plus 2 times negative 296.4 is
negative 1028.52.
negative 1028.52 kJ minus 2 times 94.3 plus 0 is
Negative 188.6.
negative 188.6 kJ. So negative 1028.52 kilojoules minus negative 188.6 kilojoules is
Negative 839.92.
negative 839.92 kilojoules. So our delta H is negative 839.92 kilojoules.
Now we have the data for the delta S and the delta H. Next is the temperature in Kelvin. The given temperature is about 850 degrees Celsius. But in order to convert Celsius into Kelvin, we should add 273 to the given temperature in Celsius. So this data would result to 1123 Kelvin. Now let's proceed in solving for delta G, or the free energy change. For our delta H, we have 839,920 joules minus our temperature, which is 1123 Kelvin, times our delta S, which is negative 161.5 joules per Kelvin. But first, we need to get the product of these two and cancel the Kelvin. So our product is negative 181,364.5 joules. And finally, we will subtract the delta H to the product of the temperature and the delta S. So that will be resulted to negative 658,555.5 joules, or negative 6.586 times 10 to the power of 5 joules. So that is our delta G for our reaction.